video for MYP Integrated Physical Science, and the topic of this video is velocity problems. The idea here is if you are working on these problems as you're studying or working on your homework, you can rewind the video over and over again. You can pause it, take notes, and if you have any questions about this, bring them to class and ask me or whatever MYP Integrated Physical Science teacher you have. And yeah, good luck. Here's 3 problems that you'll likely see in the coming week.
Alright, in this first problem here, it says that a car travels 360 meters in 24 seconds, and it's asking you to calculate its velocity. Now, there are 5 steps that we're going to do for every single one of these problems, and this would be a good point for you to pause the video and write these down. It says write the given information, write the correct formula, plug in the given information to the formula, solve using algebra, and circle your answer. And we're going to go through these steps as we solve the problem, but this is going to be true for the entire year with just about every single physics problem that we encounter. So let's do this as an example here. So in this problem, it says the first thing we're going to do is we're going to write the given information. So the given information here is that the distance is d, and that is 360 meters. And then it says that the time is 24 seconds. And the thing that we don't know is the velocity, so we'll write that right here as a v. We'll put a little question mark to show that we don't know it. Now the second step that we have to do is we need to write down the correct formula. Now in class we will get this triangle, and this is something that you'll always have on your tests and everything. Looks kind of like this. And the key to using this triangle is you're going to put your finger over the thing that you don't know. And in this case we know the d, we know the t, but we don't know the v. So I'm going to put my finger over the v, and what I'm left with is d over t. So that means that in this case, the formula that I want to write is v equals d over t. And of course that fraction means divided by. So now the next step, step number 3, is you're going to plug in the given information into this formula. So now we're going to write v equals, d is 360 meters. And I have a very particular way that I write everything in parentheses because it's a good habit for being able to deal with units. And then on the bottom, on the t, we're going to plug in what t equals, which is 24 seconds. Now, it says to solve using algebra, and using algebra, basically what you're going to do is anything that's the same on the top and the bottom, we can cancel, and we're just going to reduce this here. So in this case, 360 divided by 24, we can reduce this to equal 15. 360 divided by 24 is 15. And then we can't cancel the meters and the seconds, so we're just going to be left with v equals 15 meters over seconds. Now sometimes you'll see people write 15 meters per second, like with a little slash, and that's fine too. And we're going to circle our answer as the last step. Okay, so that's the first kind of question that you may encounter. The second kind of question that you may encounter is one where you're going to be looking for not the velocity, but in this case it says that we're going to be looking for the distance. So it says a car maintains a constant velocity of 19 meters per second, and it's asking us to calculate the distance that it travels in 10 seconds. So again, the first step is to write the given information. So in this case, we know the velocity is 19 meters per second, and that's one of the ways you can write that. It says that the time is 10 seconds, and the thing that we don't know is the distance, so we'll write that with a question mark. Next thing, we're going to plug in the formula. We're going to use the exact same triangle. Okay, in this case though, the thing that we don't know is now the D. So what I'm going to do is I'm going to cover up the D with my finger because we don't know what that is, and we're going to have a V right next to a T. So that means that if they're right next to each other, that's going to mean they're times each other. So I'm going to write D equals VT. Now the next step is we're going to plug in the information, the given information. So D equals, that velocity is 19 meters, and on the bottom we're going to have seconds. And the other given information is we're going to have 10 seconds. So because it's all multiplied, we can write that all on the top the same way. And again, I'm writing everything in parentheses because that's going to help us deal with units. So now, using algebra, I can cross out anything that's the same on the top and the bottom. So in this case, what's the same on the top and the bottom? The seconds are the same on the top and the bottom, so now they go away. And now we can multiply the numbers together, and 19 times 10, right on the next line, is 190. 19 times 10. And then we're left with our unit, which is meters, and that is our answer, so we're going to circle it. Okay, in this last problem, it says that this is where we're going to be looking for time, and this is a little bit trickier. It says a car maintains a constant velocity of 20 meters per second. Calculate the time it will take for the car to travel 1 kilometer. So we're going to handle this the same way we handled the other ones. We're going to start by writing the given information. So in this case, the velocity is 20 meters per second. And it tells us that the distance is 1 kilometer. And the thing that we're looking for is the time. We don't know that. Now, the thing that should jump out at us right away is that the units don't match. In this one we have meters, and this one we have kilometers. So that's a problem. So what we need to do is we need to use our conversion. King Henry died by drinking chocolate milk. Whoops, milk. There we go. And the idea is if we're trying to convert from kilometers to meters so they all match, we need to go from kilometers to base, because a meter is a base unit. So we're going to go over 1, 2, 3 decimal places. So when we take 1 kilometer, and the decimal starts here, we're going to move it over 1, 2, 3 decimal places, and then we'll fill in times, and that's going to give us 1,000. So 1 kilometer, instead of writing 1 kilometer, we're going to say 1,000 meters, because they mean the same thing, and now instead of having kilometers and meters, which is going to throw us off, we're just going to have 1,000 kilometers. So now we've kind of adjusted our given information so that everything matches, and now we're going to go back to the usual next step, which is that we're going to have our triangle here, or pyramid, or whatever you want to call it. Okay, in this one, the thing that we don't know is time, so we're going to cover up the t, and what we're left with is a formula where we have distance divided by velocity. So t equals d over v. The next step is to plug in the given information just like before. So t equals, our distance is 1,000 kilometers. I'm sorry, 1,000 meters, I said that wrong. And again, we're going to separate these just to remind ourselves that those units, that's a term, just like the number there. And this is where it gets a little tricky. So pay close attention to this, rewind it if you need to. When we have velocity, we have 20 meters, and that's over seconds, right? Now the problem is, look at this, we have a triple-decker fraction here, and that is no good. Now here's the nice thing, if you have, on the bottom here, we have a fraction. The nice thing is that we can very simply take this from here and move it up to here. So instead of having a double-decker fraction here, we can take that seconds and put it on the top. Now there's a very simple explanation for why this works, and I'll show you that in class. But for now, just to do this, show you quickly, the seconds is going to go on the top of the fraction. And just to keep everything neat, I'm actually going to rewrite the whole thing like this. T equals 1,000 meters, and seconds are all on the top. And on the bottom, we have 20, and we have meters. And so now we have a nice, clean version of this formula to work with. Now the next step is to solve using algebra. The first thing is anything that's the same on the top and the bottom we can cancel. So meters are the same on the top and the bottom, so they can be canceled. And now we can reduce this. 1,000 divided by 20 is 50. And so T equals 50. 1,000 divided by 20, and then the only unit that's left is seconds. So I'm going to have seconds, and that's a pretty good unit for time. So it worked out, and that's how you solve these time problems.